Okay, problem number 2 on April 20th, assignment A. We got parametric equations. We got this thing that's going on this little path from A to B to C to D. And they just gave us some rates. They gave us the rate of change of x, up and down, or left and right, sorry. They did not give us the rate of change of y. We're going to figure that out here in just a second, actually. They didn't give us x or y. They told us at the end, we're at D after 9 seconds. So the first question says, at point C, are the rates positive or negative? dy dt, dx dt, give a reason. So this thing's going from here to here, which means it's moving to the left, it's moving down, so both of the rates have to be negative. X is going to the left, y is going down, so both rates are negative. So negative rates because it's moving down and to the left. Second question says the slope at point B is undefined. When does it get to point B? So the way I did that was, since the slope was undefined, slope is dy dx, but in parametric, that's dy dt over dx dt. So dy dt over dx dt, so if the slope's going to be undefined, that means dx dt must be 0. I didn't show any work, it's just a calculator problem. It's not actually that hard, you can actually just look right there too, right? That's when you make t equal to 3 pi over 6 is pi over 2, so cosine pi over 2 is 0. So dx dt is 0 at 3. If it didn't come out that easy, just dump this into your calculator, set it equal to 0, find the points of intersection with 0. Question C says the line tangent at time 8, somewhere over here, has a slope, or it has an equation 5/9 x minus 2. What's important about it is the slope is 5/9. Excuse me. Then it says find the velocity vector and the speed. So I know the slope is 5/9. To find the velocity vector is x prime I plus y prime j. You need x prime, you need y prime. So x prime is really easy to find, yeah. It's at time equals 8. So at time equals 8, I just put 8 into this, and I got out negative 4.5. So now I also know that the slope is 5/9, right? So that means fix that again. dy dt over dx dt has to equal that 5/9. But I know that dx dt is negative 4.5. So I didn't show you the work, it's just a little equation, right? It's this over negative 4.5 has to equal 5/9, which means dy dt has to be negative 2.5. So my velocity vector is the x prime, negative 4.5a, y prime, minus 2.5j. Speed in parametric form, or in vector form, is just the magnitude of that vector. So we have this vector, this like that length. So it's just dx dt squared plus dy dt squared square root. It's just the magnitude of the vector. So we got a speed of 5.14. The last part of the question says, how far apart are A and D? So we know that I got to D after 9 seconds. So from here to here is just, all I care, if I want that distance, I just need to know how far to the left this thing went, right? So all I have to do is integrate the rate of x. Integrate this from 0 to 9. It's going to tell me how far it moved over that time period. So this on my calculator, it's a straightforward calculator problem. The integral from 0 to 9 of that gave me negative 39.25. So it moved 39.25 units to the left. So these 2 points are 39.25 units apart. Pretty good example of a parametric. No parametric on the actual test, but maybe on my final. Look for something on my final, at least one of the big topics of things that are not covered on the AB test, because we've covered them all. This is a pretty straightforward parametric equation, vector type problem.